All right. Well, the hot word of today has been performance, as we know.
.NET 7.
And we have a particularly spicy performance talk coming up from that made some people laugh. Thank you. From the Jonathan Peppers.
The Peppers.
Talking to you about performance improvements with .NET MAUI and .NET 7. So take it away, Peppers.
Hello. Hopefully this is spicy. I'll have to live up to that. But yeah, I'm talking about performance and what we did in .NET 7 for .NET MAUI. So hopefully, the things I'm going to go through, hopefully you can use these ideas in your own apps. So this is useful even if, maybe you're just a regular .NET developer on some other type of project. It could be helpful to you as well. So about me, I am an engineer I was an engineer on Xamarin Android, and now it's kind of an area where we don't know what to call it, but the Android workload for .NET or .NET for Android. But I do a lot of things with MAUI in general, and so I end up working on things like performance or problems with the build or workloads, anything like that. So let's get into it. So everything I'm going to talk about today was in this blog post, AKMS MAUI -7-perf. If you want to check that out after it, there may be things on there that I don't mention. There may be details and links and other stuff that maybe I am going to gloss over here. And obviously, if you're coming from Xamarin, you may want to look at the .NET 6 version of this post. And so I linked to the one 6 months ago. That gives you the details of any of the benefits you'd get just moving from Xamarin to MAUI today. While here I'm going to talk about .NET 7, right? I'll also give a quick recap on how to profile your own apps, because that's different on every platform. We do have some documentation on this. I'll kind of link to some things like that. And of course, I'm going to give some specific examples of the performance improvements we made in .NET 7. So let's get into it. So we had these goals back when MAUI was shipping, that we had the problem where iOS started up fast, but the app was large, and Android had the alternate problem where the app sizes was good and we had problems with startup. And so we had these goals of 800 milliseconds on a Pixel 5 for the .NET podcast sample. And we also had the goal to get around 10 megabytes for the .NET MAUI template on iOS. And we made some really good strides toward those goals in .NET 6. We got to 812. We got really close on startup, and we moved the needle on app size as well. But as we moved to work on .NET 7, we had customer feedback that we needed to focus on different things, right? We had customers said, okay, yeah, mobile. What about desktop? What about desktop startup? And then also we had a lot of comments about Android scrolling and layout performance. And so instead of focusing more on these numbers, we focused on some of these other concepts at the same time. Now, we still ended up making some improvements in 7. So you're going to get faster startup, smaller apps. But I think we really did focus on the right things in this release. So let's go into that. So these pictures here, I think you probably saw those on David's slide a few hours ago. I don't know how long ago. And what this app is, this is an app that was on Reddit a few years ago, a different version of this app, where they put a random label on the screen, rotated random color, and then did that as fast as you can and just measured how many times per second you could do that. And so I wrote my own version of this, mainly because I just wanted to make sure that it was correct, and I wanted to base it on Java with no .NET in it, to compare the performance of that versus moving to .NET versus using MAUI versus maybe using Xamarin Forms. So I'll talk more about that in a minute. But in profiling this app, we could see some of the performance issues in layouts in .NET MAUI. And the things that we fixed there directly translated to this second picture. So this is running on a Pixel 4a. It's just a collection view with 10,000 rows of 2 data-bound labels. This is something that should be able to scroll fast. And you can see on this older device, as you scroll to the top in .NET 6, you can see the bars are high, and in .NET 7 they're lower. It's a little tricky to get a solid number of how much we improved here, but I think this is the visual decent representation of what we did. So this is that same LOLs per second app. I talked about how I wrote the same thing in Java, C#, MAUI, and then we had someone contribute Xamarin Forms. And so Java is kind of like the ceiling of where MAUI could ever get, because it's using Android widget text view. That is the underlying control that is a label in MAUI. And so the C# version of that is the same thing, except we have the cost of interop from C# into Java. And we're going to keep working on making that even better, but that's another ceiling where MAUI is not going to be able to pass that mark. And then you can see on the far left is where we were in Xamarin Forms. And .NET 6 already had made some good strides between those two, but the yellow bar here in .NET 7, we really did close the gap between .NET 6 MAUI and the C# sample. And maybe we can keep doing that for even further in further releases. So desktop. So what we wanted to do here is really focus on the biggest wins we could get. And I think we were able to do that. This picture here is an app running in a lab on some Azure DevOps hosted pool or something. So don't worry about the number so much. But when we first got it running, the .NET Fundamentals team has this running for us. We noticed that ready to run wasn't turned on, right? And so as soon as we turned that on, that's what the graph did. So this is a setting that is kind of similar to AOT, but it's really what you get on Windows right now. And it's a setting that's on by default for WinUI 3 applications already. So it made sense for us to just turn the same setting on by default for release builds in MAUI, and we've done this in 7. So you could turn this on yourself in 6, but we're going to do it for you if you just to make things easier. And similarly, we have another setting for Mac. So we had a customer who, they were reporting that their app was taking like 3 or 4 seconds to launch. And then they would launch it a second time, it would be fast. And it turns out that they were compiling their app for x64 and running their app on like an M1 MacBook Pro. And so they were seeing that's Apple's, Rosetta translation technology that makes that app able to run. But all they needed to do was build it for 2 architectures. And so we made the change in .NET 7 that the Mac OS and Mac Catalyst workloads, it's going to do this for you by default in release build. So you don't have to know about this. You can just build a release build by default and send it to the App Store, and it should do the right thing. So those are 2 big wins for desktop startup. And hopefully, this has an impact in customer projects. So let's talk a little bit about profiling your app. This is always a little tricky, and hopefully, we have documentation that'll help with this. We tried to link to different sources, like, hey, here's a link to Apple's documentation. Here's a link to Google's documentation. But hopefully, this is a useful section for you. So we created a landing page on a wiki on MAUI's repo, but you can get there by AKMS/profile-MAUI if you just want to learn more about this. I'm going to give some examples here. Ideally, one day you'll click a button in Visual Studio and it can do some of these things. But we're not there yet. Hopefully, in one day we'll get to something like that. So an example of how you do this on Android is you run a bunch of commands that sets .NET Trace to where it could talk to your app running on a remote, like Android device, right? And so once you run these commands, a speed scope file comes out, and you can go to speedscope.app, and it's kind of like a local web app. It doesn't upload your file anywhere, but you can look at your trace at that website. And you can also install a command line app if you'd rather do that. But in this example, this is looking at the initialize component method, which is an interesting method if you have a lot of XAML. And if you click on that, you can drill into it and get a view, something like this, where this is a giant graph of the method and everything it called. And so the wider the bars is how long things took. This is just an example, not particularly anything interesting here, but this gives you an idea of what SpeedScope can do. So startup time. So one thing about SpeedScope, and maybe probably any profiler, is the times that it tells you are probably a little higher than what they are in real life. It's like the act of measuring your app slows it down, right? And this is particularly true on mobile. So a lot of times what we do is we'll profile a change and then measure the change again without profiling. So the question is, like, how do you do that? How do you measure the overall startup of your app? So that same web page, profile-maui, has a section on measuring startup times. And the way you do this is just completely different on each platform. Android has this log message. It says like activity task manager, and it prints out how long the activity took to launch. iOS has a similar log message, but then you can use Xcode and instruments to do the same thing. And for desktop apps, it's kind of even worse in that there is no log message that tells you how long the app took to launch. And so what I recommend doing is printing out your own console write line message. And then I have an example project here that launches a process and waits for that message and gives you an average time. And so this picture at the bottom is an example of running some real app that was doing stuff. Like, it really took 1.4 seconds to launch. But yeah, this might be a handy tool. You might check it out if you need to look into something like this on desktop. Yeah, so now let's talk about some specific examples of like stuff we did in .NET 7. Some of these things are a little heavy. We'll see how I do. I'm going to try to explain it. We'll see how it goes. But yeah, well, let's get into this. So one of the first things when we got Maui running on .NET 7 is that we noticed a regression on Android. And so this is just kind of a story of something that happened, and I thought it was interesting, so I was going to pass it on here. But what happened is the apps were about 1.5 megabytes bigger, or a particular file was, and at the startup time was 250 milliseconds worse. And so we did some investigation with the mono runtime team, and we found out that the Android NDK changed the compiler flags when building C and C++ code by default. And so in .NET 6, it was using 02. In .NET 7, it used 03 on accident. Like, this wasn't something that we changed. And so we tested all three of these, and we settled on the one that was good, and we got us performance back. This is just an interesting thing. If we weren't watching performance like we do, potentially this could have been released as an issue. But we like to stay on top of things like this so that we don't actually ship them. And so another interesting thing Mono team worked on, DateTime.Now. So we had a customer report their app. It was using DateTime.Now, and we could see that it was like 277 milliseconds added to startup just by accessing Now. And the code that was running there is just what happens when it loads the time zone data to figure out what is the current value of Now. In that customer's app, it turns out that they could just use UTC Now. And so that's what they did. Yeah, I recommend doing that. If you don't really need the local time, just use UTC Now. But we know that this is a common API that everybody is going to use. Like, it shouldn't be that slow. So what we did is we did some refactoring where um, in Java, we could get the time zone offset in app startup and then use that value as needed, right? And then a background thread can go off and load the time zone data that may be needed by other APIs in the base class libraries. So this was a great change. So that 277 milliseconds down to 17 or 18 or so milliseconds, this is going to be good for everyone in .NET 7. So here, this is a change. Okay, so color state list. This is a change in MAUI. So color state list is an Android API that it lets you pass up for a button, for example, all the different states of that button and what colors things are. So this is very, obviously useful for MAUI to use, right? Because it needs to change the colors of all the states on a button, right? And it's just unfortunate that this API is shaped the way it is, that you pass it a multi-dimensional array of integers. And if you look at this code example here, under the hood, it has to create a Java array and copy all these elements over so that Java can access the elements in the array, and C# is able to pass the values in, right? And this is a noticeable thing in startup. In this trace here, it was like 17 milliseconds just of calling color state list. And so the solution for us in MAUI is that we can move the code into Java, right? MAUI has a Android Java project where we can put code in there, and then we can create our own internal APIs to make things faster when doing interop into Java. So here's an example of what our Java code looks like. So instead of passing in this crazy integer array, it's just a single color for the default color state. And so for like an edit text, that's actually like an entry. We only need to pass in 2 colors, right? And then all the default values are in Java, so it's not something that we even pass through between C# to Java. And then C#, the APIs are not that tough to use. We just basically call a static method to get the color states that we need. So this was a good change, completely invisible to MAUI developers, but maybe you'll notice your app starts a little better. This is something we did for edit text button, radio button, maybe a couple other controls like that. Okay, regex options. This is another interesting one. So if you're a .NET developer and you're building a web service, a website, regex options compile is probably great, right? It does exactly what you want. It does a little more work as your service starts up, and then for every incoming request, your throughput is very good because it's already done that work up front. Now, unfortunately, if you're building a mobile app or like a desktop app and you create a regex and let's say you use it once or only a couple times, this actually might be worse for you, right? So we had an example where a customer, they migrated from Xamarin Android to .NET 6, and they noticed that their regexes were causing problems in startup. And in this example here, it was like 174 milliseconds to create the regex and then 49 milliseconds to match on the first match. So that sounds pretty slow. And in their case, they could just not use compile. The difference why it didn't happen in Xamarin Android is the old version of Mono, this feature didn't actually do anything. Regex option compile didn't do anything. It's the same as normal. So they just moved to normal, for now. Now in .NET 7 though, we have something even better. We have source generators, right? So instead of using regex options compiled, you can rewrite it to use an attribute, and you create a little method and you decorate it with regex generator. And it has all the same features that you had from creating the regex yourself. And the difference is it generates C# code to kind of implement your regular expression so that it is fast. And in this example, I tested this on Android, but those times that I had before, there's like 200 milliseconds worth of stuff, 200 and something, yeah. So it's down to 6 milliseconds. So if you have regular expressions in your app, I would absolutely use this today in .NET 7. And so there's one more picture on here. This is the times of when I wasn't profiling. If you wanted to see the overall app startup time, it did save almost 100 milliseconds, like 90 something. So this is a great feature. So here's another change we did. This is in MAUI itself. This is another thing related to Java interop that maybe folks aren't aware of, but if there's code in MAUI where it was calling context, the context property multiple times. So this is just a code snippet, it's getting some widths and heights and called context. Well, there's something happening behind the scenes there on each call, is that C# calls into Java and we get a handle back, which is like a system.end pointer. And we have to take that handle and find out if we have a C# object alive with the same handle and keep using it. And so if that is happening, you could just move context to like a local variable here instead of calling it 4 times. We went beyond that. In some cases, we'd make like a member variable in the class so that it happened like once for when the view is created, and then it never happens again. And so this type of fix here, this improved the number of LOLs a second we got in the app I mentioned way earlier, as well as like things like CollectionView scrolling. So this is a good change, right? Here's another change in MAUI related to layout. So when profiling the LOLs a second app, you could see here there's several calls. There's a measure call, and then a get measured width and get measured height, right? And looking at the code, it was very straightforward. It's just measuring and getting 2 integers. But that crosses from C# to Java 3 times. And after thinking about it a little bit, what we could do is instead write a method where we can cross once. And so what we do is we pass in all the values we need, the view and the 2 width and height measure specs. Don't have to worry about what that is, but and then we could pack the 2 values we need into a single long. And then on the C# side, we could unpack the values that we need into integers as we need. And this is something that always be skeptical that this is going to be faster, right? Only through measuring before and after did we actually realize that this is even a good idea at all. And so you can see here that I think this is a trace of the LOLs per second app, but a method called get desired size from handler is what was doing all this work, and we could see it had a good impact to performance. We could also see more LOLs a second, which is always good. Too many LOLs. So another thing, so let's talk about CollectionView. We've seen quite a few issues filed on CollectionView, don't worry. And so we had a case where a customer, I don't know what they were trying to accomplish, but what they had was a layout with a page, a scroll view, a vertical stack layout, and then a collection view, right? So maybe their layout is more complicated and this is what they ended up with, I'm not sure. But what happens is the collection view expands the vertical layout as high as it'll go, right? And so every row will actually fill out its contents. So this made the app start incredibly slow if you have this set up. So in .NET 6, that app is taking like 16 seconds to launch. In .NET 7, we got it a little better, it's 14 seconds, but that is really slow. And in this example, we could simply remove the extra scroll view and vertical stack layout for a 94% improvement. Obviously, we don't want people to do this on accident. It seems like an easy pit to fall into, so we're still coming up with ideas of how to make this better. But I mean, I use things like this back in the WPF days, and I've done this on accident in WPF. So, this is something that maybe we can figure out for Maui. So let's talk about some app size changes. If you're using .NET MAUI today, you actually are using some Kotlin libraries, and maybe you don't even know it. And so Google has been slowly transitioning things to Kotlin. And so as they do that, random Kotlin stuff has appeared in apps. And so we have added a feature to exclude those files. And so it excludes these by default in .NET 7. And the thing that's useful about this is you could use this to exclude other files if you need to. All right, and I think this might be the last thing, app size. This is for iOS app size. If you look at the AOT output for an iOS application, it does stuff for generic methods so that there's a set of code for value types and a set of code for reference types. And it was emitting both always in .NET 6. And so we made a change so that if you don't have any reference types that use this generic method, then it doesn't emit both. It just emits half of it. So this was an app size improvement for iOS, and that's pretty good. So last thing, these are some of the themes for .NET 8. Obviously, we might change. We get feedback. We'll see what happens. But we want to work on fundamentals like bugs, like performance. We want to work on more layout and scrolling performance. We also want to work on the inner loop. So this talk, if I give it next year, maybe I'll be talking about build performance. Who knows? But yeah, I think that's all I have on performance. If you want to learn more, there's my blog post, AKMS Maui -7-perf. But I think that's all I have. Back to you guys, Maddie, Matt.
Oh, Peppers, that was amazing. I love hearing the performance improvement post. Peppers, that was so much in there.
So much.
How do you do it?
What was your favorite performance improvement in all of these ones for .NET 7, Peppers?
I think it may just be simply like getting the right default values for people's apps, right? Like ready to run, Mac, yeah.
That's awesome.
That would probably be it, yeah.
And how long did the blog post take you to write? Because I know it took me about 4 days to read.
I should write down. I don't know. I think it took me at least one full working day, if I had to guess. Yeah. So.
That's not too bad.
That's quick.
Yeah.
That's super
fast.
quick.
Almost as performant as .NET MAUI.
Peppers is performant. Oh, Jonathan, you really you put up with a lot. From us.
He really does. Thank you so much for joining, and thank you for the blog, and of course all the work you do too. You don't just talk about these things; you actually do these things, which is more than I can say. So.
Thanks, Jonathan. We appreciate it.